Alright, so today we are going to talk about another type of function. We're going to go back and look at your table of contents, your functions list. I've forgotten to put one on, so evidently I need to take that one off and put another one on. So yesterday we did finished piecewise functions, which was 44 and 45. Better check that. Yes, 44 and 45. There's another one that goes right here that I've forgotten, and that's 13.2, graphing absolute value functions. So we're going to add that one in. That's what we're doing today and tomorrow. And that is 146 and 47. I can't believe I forgot one like that, but oh well. I did. Alright, so we're going to talk about graphing absolute value functions. So on 46 and 47, you can go ahead and label it 13.2, graphing absolute value functions. And we're going to do that today and tomorrow. So remember, if you don't have a printer or something, you don't have the handout, you are just going to write it in here on this page. Okay, so put that to the side. Let me get out the foldable. So our foldable, we got 7 problems. We're going to graph them, then we're going to write equations as well. So looks like this. That's a blank piece of paper. It looks like this. We have Vertex Form up here in the top. We're going to talk about Vertex Form. And we are then going to graph these. So Vertex Form right here is very important. We have 3 special pieces. We have A, which acts like slope, by the way. We have H. Notice it's minus. So whatever's on the inside, we're actually going to do the opposite of that. And then we have K. H and K are the vertex. So the vertex is H, comma, K. See how H is negative here, but it's not here, so we will put the opposite in. K is positive, K is positive, so we leave K alone. All right, so the first thing we're going to do for all of these is identify A in the vertex, then we're going to graph it, and then find all of these pieces. So A in the vertex, then graph. So A is the number in front here. There is not a number in front, so A is 1. The vertex is H, comma, K. H, we do the opposite. It is currently minus 1, so we put positive 1. K, outside of the parenthesis, outside of the absolute value symbol, is negative 1. So we change or take the opposite, we leave it alone. We are going to put a point on 1, negative 1, and then we're going to use A. A is like slope. So slope 1 means we actually go up 1 over 1. So up 1 over 1, up 1 over 1, until we run out of room. Now, here's what we need to know. I'm flipping back to page 38, where we had the different types. We're talking about absolute value functions today. Absolute value functions are a V. That means this should be a V. In order to get the V, once I've gone up 1 over 1, I'm going to go back to the vertex, and I am going to go up 1, left 1 to make the V. I will have both sides of the absolute value if I do that. Then using a straight edge, connect. Okay, now we're going to identify x-intercepts and y-intercepts. So here's my vertex. I'm going to highlight my x-intercept in orange, y-intercept in pink. We already identified, here's the vertex right here. By the way, it is possible to have more than one x-intercept. It's possible to have no x-intercepts. It's possible to have one x-intercepts. You could have 0 intercepts, you could have 1 intercept, you could have 2 intercepts. All right, x-intercepts is where it crosses the x-axis. It crosses here and here. So our x-intercept, the first one is 0, 0. Our second one is 2, 0. Y-intercept is where it crosses the y-axis. Crosses the y-axis here. That is also 0, 0. If you have 0, 0 as an intercept, it's both intercepts, by the way, always. All right, in behavior. When x goes towards the negatives, x approaches negative infinity, and when x approaches the positives. That should say y and y. Okay, when x, we're looking at the left side here, goes towards the negative numbers, y is positive, so it's going up, so it's positive infinity. On the right side, when x goes towards the positives, y is also going towards the positives. Remember when we had lines, it was the opposite, like you always had a negative and a positive? On absolute value, you're always going to have the same. It's either going to be 2 positives or 2 negatives. All right, domain. Domain, this goes forever, left and right in both directions. So it is all real numbers. Remember that symbol, or you can write all real numbers. Range. Range does not point up and down in both directions forever. So what we have to recognize is what point does it start. The y values start at -1. So my range is all the values that are larger than -1 or equal to. So y is greater than or equal to -1. That's the range. All right, number 2. First thing we're going to identify is A in the vertex. There is no number here, so A is 1. The vertex, we have the opposite of 4 and -1. So the vertex is -4 because we changed that value, and -1 because we leave that value the same. So put a point on -4, -1. A says we go up 1 over 1 until we run out of room. Once we run out of room, we're coming back to the vertex to go up 1, left 1 until we run out of room. Sometimes it looks more like a check mark. That's fine. It's still absolute value as long as you have both sides. You need both sides. All right. We've already identified the vertex. Let's find the x-intercepts and the y-intercepts. X-intercept, it does have 2. One of them is at -5, 0. It's got another one right here at -3, 0. Now let's find the y-intercept. Crosses the y-axis here, so that's 0, 3. All right. In behavior, when x is approaching negative infinity, y is approaching, well, on this side over here, y is pointing up, so infinity. When x approaches infinity, y approaches infinity. Okay, domain is still all real numbers because it points in both directions forever. Range. This does not start until -1, so y is greater than or equal to -1. All right, I want you to pause the video and try 3 and 4. Okay, now that you've paused it, still identifying A and the vertex first. A is 1. That actually is true all day. The vertex is the opposite, so positive 1, and the same, so positive 3. So put a point on 1, 1, 2, 3. And then go up 1 over 1. Okay, and connect it. You absolutely should be using a straight edge to connect it. All right, the x-intercept is where it crosses the x-axis. It doesn't. I don't write 0, I literally write none, and I don't want you to leave it blank because writing none lets me know that you looked for it, but you didn't find one. You need to write none. The y-intercept. It does cross the y-axis at -4. So 0, not -4, +4. 0, 4. Okay, in behavior. When x approaches negative infinity, y approaches, going up, positive infinity. When x approaches infinity, y approaches infinity. The domain is still all real numbers. The range is what's different on this one. The range, this value, these y's, do not start till +3. So the range is y is greater than or equal to +3. In case you haven't noticed, the y value of the vertex and the range match. Okay, you should have paused it to do number 4. If you haven't, pause now and do number 4. A is still 1. The vertex is -2, 2. So -2, 2, up 1 over 1. Go back to the vertex and go up 1 over 1. This doesn't cross the x-axis, which means it's not going to have an x-intercept. So none. The y-intercept, it crosses at 4. The end behavior, when x approaches negative infinity, y approaches, it's going up, so infinity. When x approaches positive infinity, y approaches positive infinity because it's going up. We will have some tomorrow where this is different. Today we just have a is 1, so that will change that for us. All right, the domain, still all real numbers. The range is y is greater than or equal to +2. All right, now let's talk about how to actually write the equation. Every time we've graphed this, what we've needed is a and the vertex, which means when we go over here to write equations, we're going to need a and the vertex to write the equation. We're not doing any of this. We're only writing the equations on numbers 5 through 8. So first, we're going to identify the vertex. The vertex is at -2, -1. A, since it's going up 1 over 1, is 1. So A is 1. The vertex is -2, -1. We are going to write this using our vertex form here. Right here. Y equals A, which is 1. You can put a 1 or you can leave it blank. Absolute value of x. Then we put in the opposite of what our x value is. So we put +2. Absolute value -1. Here is our equation. Number 6. Up 1 over 1, so A equals 1. The vertex is -2, -4. So y equals, we don't have to put 1, so we're going to start with absolute value. X, opposite, so +2. Absolute value, -4. I want you to pause the video and do 7 and 8. All right, 7. A is still 1. The vertex is -3, 4. So y equals, again, we don't have to put 1, so we skip the absolute value, x plus 3 plus 4. All right, and number 8. A is still 1. 2, 0 is the vertex. This one's going to be a little different. You're going to see why. So y equals, we don't have to put a, so we put the absolute value. We don't put a because it's 1, not we don't have to put a. We put x minus 2 because we do the opposite. But then we have 0. We do not have to put plus 0. If you did, that's fine, but erase it now. You don't have to put any of that. Just put -2. All right, we're going to glue this in. Tomorrow we're going to keep talking about this. So glue this in on page 46. Okay, and we'll talk about this some more later.